Okay guys, I'm Eugene. Welcome back to the series of the differential questions and the applications that we began. And before we start, don't forget to like and subscribe to the channel. Today we're going to be looking at the question which reads: a piece of wire 48 centimeters long is divided into two parts. One part is formed into the shape of a circle of radius r centimeters, while the other part is formed into a shape of a square of sides x. Okay, part A says show that r is equal to 24 minus 2x over pi. Then part B, find an expression in terms of x for the total surface area A of the two shapes, and hence calculate the values of x for which A is a minimum. Okay, with that in mind, we know that this wire has been folded or forged into a circle of radius r, not so, and a square of sides x, like that. But we know that a combination of these two is going to give us the total length of the wire, which is equal to 48, like that. Okay, so our job is to find the perimeter of the circle and the perimeter of the square that we have. Okay, we all know that the perimeter of a circle is given by 2 pi r, and the perimeter of the square that we have is just x plus x plus x plus x, which is equal to 4x, which we are now equating to 48. Okay, so now our job is to express r in terms of x, or making r the subject of the formula. So we're going to have 2 pi r is equal to 48 minus 4x. Then we're going to divide both sides by 2 pi. 2 pi, like that. Even this side, 2 pi. Okay. So with that done, our r is now going to be equal to, we can see that we can factorize a 2 on the numerator, which we're going to have 2 open brackets 24 minus 2x over 2 pi. Don't mind the noise in the background. So the 2 will cancel out. Then r is going to be equal to 24 minus 2x over pi, hence shown like that. So we're done with the first part of the question. So what is the second part asking us to do? So part B is saying find an expression in terms of x for the total surface area of the two shapes, and hence calculate the values of x for which A is a minimum. Okay, so we know that they want an expression for the total surface area. So total surface area, TSA in abbreviation, which is going to be the summation of the total surface areas of the two shapes. So we all know that the total surface area, or rather the surface area of the circle, is given by pi r squared, summing it up with the surface area of the square, which is just basically L times B. So the total surface area, which is just basically the area, so I'm going to denote it by A now. A is going to be equal to, okay, so to begin with, the total surface area of the square, we all know that this is our L and this is our B. So x times x, which is just basically x squared, plus pi, and we know our r. Our r, from what we derived, our r is 24 minus 2x over pi, and that squared. Okay, we can do a little bit of mathematics here, whereby we expand this part. Then our area is going to be given by x squared plus pi, so numerator squared, which is just 24 minus 2x squared, over denominator squared, which is just pi squared. And we know that when we do some simplification of this, the pi on the numerator is going to cancel out with one of the pi's in the denominator. So our expression now is x squared plus, so I'm going to pull out the pi in the denominator, so that I have 1 over pi multiplied by 24 minus 2x, that squared. Okay, so this is our expression. This is our expression for the total surface area in terms of x. Okay, now we're remaining with the last part of this question, which is now asking us to calculate the values of x for which a is supposed to be minimum. So when we look at where we're coming from, we've been told, and we all know, that to maximize the surface area, or to minimize the surface area of a shape or an enclosed surface, so dA dx should be equated to 0. So our job now is to find, or to differentiate, the area function. So dA dx is going to be equal to 2x plus, so here we are going to use a bit of some chain rule to find the derivative of the second part of the area function. So 2 over pi, open brackets, 24 rather, minus 2x, multiplied by the derivative of what's inside, which is just negative 2. Okay, therefore dA dx is going to be equal to 2x minus 4 over pi of 24 minus 2x. That we have the derivative of the area function. Now the job that we have at hand is equating dA dx to 0. So when we do that, we're going to have 2x minus 4 over pi multiplied by 24 minus 2x should be equal to 0, like that. Okay, so we can expand the second part. We're going to have 2x, that when we expand, we're going to have minus 96 over pi plus 8x over pi being equal to 0. Okay, so when we continue with our computations for finding the value of x, we're going to take this to the right hand side. Therefore 2x plus 8x over pi is going to be equal to 96 over pi. We can factorize the x variable here because we know that it is common. X, so 2 plus 8 over pi is equal to 96 over pi. Okay, what is going to happen is that we are going to combine these two because pi is a constant. When we combine these two, what we're going to have is 2 pi plus 8 over pi, which is equal to 96 over pi. Therefore, we need to divide both sides with 2 pi plus 8 over pi on both sides so that we remain with x on one side. Because our job, don't forget the aim of this question, is finding the value of x. So when we do that, x is going to be equal to 96 over pi divided by 2 pi plus 8 over pi. We all know that the denominator is going to become the numerator, 96 over pi times pi over 2x rather plus 8. The pi and the pi are going to cancel out, and then we're going to remain with 96 over 2 pi plus 8 as our x value. But we know that we can simplify this further by factorizing out the 2 in the denominator. So our x value is now going to be equal to that. When we factorize out the 2, we're going to remain with 48 over pi plus 4. Okay, that is our x value. That's going to minimize the area, the total surface area rather. With that done, we can call this question as a deal done.